Hello students. Today we're going to continue talking about linear functions, and we're going to talk about a special kind of linear function called direct variation. This is from section 5.4 in your algebra book, which we'll get later. But direct variation is a special type of linear function written in the form y equals kx, where k is the constant of variation. And you're probably looking at that equation and thinking, Mr. Cohens, that's the same as y equals mx. And if you said that, you're exactly right, because k is exactly the same thing as m, which is the slope. We just in math decide to call things different things because, it makes it more fun. So in an equation, y equals kx, you could also write that as y equals mx, but you notice something's missing. There's no plus b. For direct variation, there's always going to be 0 for your y-intercept, which you'll remember from last year. If 0 is the y-intercept, it passes through the origin. So direct variation is y equals kx, and k is the constant of variation. So what do I have to do to x to get to y? Is basically what it's asking. So it could look in several different forms. I could have y equals 1/3 x. And that's a constant of, that's a direct variation equation because it's in the form of y equals kx, and k, the constant of variation, is 1/3. I could also look at it a different way. I could also say that x over y equals 2. Really? Could I say that? Well, let's see. If x over y equals 2 and I multiply both sides by y, I get x equals 2y. We're close, but no cigar. So now I divide both sides by 2 and I get y equals 1/2 x. Is that a constant of variation? Yes, 1/2 is my constant of variation. Is that a direct variation equation? Absolutely. Because y equals 1/2 x. So if the form is given to me as x over y equals 2, I still understand that that can be written as direct variation. I just have to do a few steps to get there. What about this one? What about x, that should be a y. Y equals 2x plus 3. Is that direct variation? I think I heard it. No is the correct answer, because of this plus 3. That plus 3 makes it not direct variation at all, because I have a y-intercept that is not 0. 0 has to be the y-intercept for direct variation. So y equals 2x, if it was just y equals 2x, yes, but y equals 2x plus 3 is not direct variation. Well, what if I'm looking at a table? If I'm looking at a table of values that have x's and y's, how do I know if that's direct variation? Well, let's create a simple xy table, and we're going to have 1, 6, 2, 12, 3, 18. And I need to figure out if this is a direct variation function, linear function here. And so, but before we do that, let's look at something. In the form y equals kx, what if I wanted to solve for k? How would I figure out if there's a constant of variation with the k? Well, to solve k, I have to divide by x on both sides. So k equals y over x. So if I'm given a table, I can look at y over x and see if the k is the same for every one. So this would be 6 over 1 equals 6. And this is 12 over 2 because y over x and that equals 6, and then I have 18 over 3, and that equals 6. So this table represents a direct variation function, and the constant of variation would be 6. So I could write the equation y equals 6x, and that would be my direct variation equation from this table. Again, to find k, I just do y over x. Well, let's look at another table, and let's see if this other table is direct variation. If we have 2, 8, 6, 54, and 10, 80. Let's see if this is direct variation, okay? So I do 8 over 2 equals 4, and I do 54 over 6, and that equals 9. Those two k's are not the same, so this is not direct variation. K has to be the same for every ordered pair in order for it to be a direct variation equation. So now we have a situation. 2 yards of fabric costs $15. How much is 7 yards? The instructions tell me that this is a direct variation situation. So I need to write a direct variation equation to figure out the answer. So first of all, we need to figure out what we know. We know that 2 yards of fabric costs $15. So we're going to go with yards of fabric and the cost of y. Yards x, that's kind of really bad, but oh well. Okay, so we know that the yards of fabric is 2 and the cost is 15. Well, they told me it was a direct variation equation, so that means I can find k by doing y over x. Okay, they told me that. I didn't have to guess. It was in the instructions. I just didn't write the instructions. They told me it's direct variation. If that's the case, if they tell me it's direct variation, then k is always going to be y over x. Well, what's y over x? That's 15 over 2. Well, 15 divided by 2, if we're talking money, is $7.50. So we know that k equals $7.50. So my function in equation form would be y equals 7.5x. So I've just figured out what k is by doing y over x. And now that I know the k, I can plug it into my equation, y equals kx, or y equals 7.5x. And then the question is asking me how much is 7 yards. Well, 7 yards is x, so 7.7 times 7 is 49, 50, 51, 52, 50. So in this case, 7 yards would be 52.50 if I did the calculations correct, which I think I did. So, taking a situation that we know is direct variation, finding the constant of variation, y over x, and then plugging it in to our direct variation equation and solving our problem. Just a few simple steps. If I was graphing this, just remember, anytime we're graphing a direct variation equation, it's always going to go through the origin because plus b is plus 0, which means my y-intercept is 0. And here are your 3 practice problems for tonight. The first one, which one or ones represents direct variation? You've got choice A, y equals 3x plus 7, choice B, y equals 1/4 x, or choice C, y over x equals negative 7. Which one or ones represent direct variation? Number 2, is this direct variation and why? Looking at this table right here, does it represent direct variation and why? And number 3, Bill earns $15.50 per hour. Represent this with a direct variation equation. It is direct variation. I just need the equation. Take a picture of your practice problems and submit it using the turn-in button at Edmodo.